My objective for the session is saying a few things that can be interesting, important, and of learning nature for you guys. Of course, I'll be talking about a case that talks also about our technology. So I mean, I'm biased in promoting it, but I really want to talk about the market problem and about stuff that is useful in general, not just about our products. So that's my personal goal. And in terms of specific agenda, ideally, I would like to say two things about Vinnova for people here that don't know who we are and what Perseus is. Then talk about market landscape, what is happening with live streaming, live linear becoming important in OTT and the challenges thereof. Then we'll talk a little bit about Sky and what Sky over IP is doing. Actually, Sky over IP is not a very famous service here in the US or across the globe, maybe, but admittedly, as far as we know, having spanned the entire globe, is the most performing OTT service over our managed networks. And I'll say something about it and why this bold statement. Then we will talk about available options to deliver TV-like experiences today, and then some questions, answers, and summary items. Very good. How many of you already know who we are as Vinnova, what Perseus is? Exactly, we talked about it. Okay. There's a lot of talk about codecs and about codec war, and very often people mention HEVC, AV1, VP9, and Perseus sometimes gets mentioned. So we are that one, the one that gets mentioned less because we are a small company, and so our marketing budget is not that strong. As Vinnova, we focus on unique compression solutions that make image and video experiences come alive. We are really passionate about improving the quality of experience of digital delivery. And what we do is the best codec formats around, compatible with all devices and usable today. We won a lot of awards, which don't mean much, but we did. We have a dedicated team of very highly skilled people in London, about 60 people in London where our headquarters are. Actually, this is Sheldon Square where our offices are. We also have a satellite office in India and also one here in the US. And we also power Tier 1 operators like Sky and Eutelsat, both of whom also became minority shareholders after being our pilot customers. So we also have a good track record with pilot customers investing in us because they like what they saw. Enough about us and Perseus, and more about the market. We're in a beautiful moment, and as Vinnova, we are incredibly happy about the fact that 2018, finally, after years of waiting, is the year where OTT is truly being promoted to live linear delivery. For years, OTT has mostly been associated with Netflix-type services, so VOD, film, TV shows. And now, finally, we are seeing companies that are making bold investments, billions of dollars in rights purchasing, also exclusivity, and delivery over a managed OTT networks. This is great because OTT really has the power not just to create TV-like experiences for the masses, but also to enhance them, to do something more, to add interactivity to live linear delivery. And live linear delivery is what people do for 90% of the watching time because it's sports, it's news, it's real-time stuff. It's something that has a lot of emotional value and also dollar value, monetary value, because it's where the majority of the money is. And we are seeing also that people are starting to experiment with models that can really deliver more and enhance the quality of TV. Also here in the US, we are seeing with ATSC3 the potential to transform really the way TV is being watched with pop-up channels and a lot more interactivity, but also we are devices we can upsell via e-commerce, provide additional information, etc. The important thing is, however, the basics and the fundamentals should be okay. So at least video delivery should be TV-like and high quality, what we came to expect from digital terrestrial, from satellite, from cable. And the problem is currently it's getting messy out there. We've seen in the past months that every time essentially we have some large events, we have some kind of big problems. We saw it in the US, we saw it in Australia, we saw it all across the globe with the World Cup. We saw it in my mother country with an operator being sued by 2 consumer associations for bad quality soccer delivery. So it's currently a problem. It doesn't work as well as people would like. And why is that? Why is live linear so difficult? And in particular, when people now got used to the fact that VOD more or less was working pretty well, then they're noticing that live doesn't work even nearly as well. And this is for good reasons, because everything is different from live linear versus VOD. First of all, encoding happens in real time, and the content is typically more challenging. When we talk about live, very often we're talking about sports. Sports content is very challenging. Sports also is live, and this means that there is less time to process the video. We cannot run 500 parallel encodes overnight and do multipass encoding or complex dynamic optimizations, content-aware encoding. None of that is possible. It's real time. You have a few milliseconds, single pass encoding, and off you go. And also, encoding processing power is very costly. So while 100x more processing power dedicated to encoding is doable for Games of Thrones, which you encode once and use for 10 years, you cannot do it for live linear at all. Then there's also a problem with delivery, because latency is critical, and as a consequence, there's less room for caching. Essentially, while for VOD, we have the luxury of repositioning contents to the caches of edge servers whenever we want. We can take even a week if we want to do it in advance. With live, it needs to happen in real time. It's all immediate, which creates a lot of bottlenecks, not just in the last mile, but also across the backbone in the whole chain. So also the pipes that feed edge servers are problematic. Also, traffic is in sync, so we need to use constant bitrate. We cannot use variable bitrate strategies, because otherwise we would create quality of experience problems with traffic going up and down all at the same time, because typically people are watching exactly the same chunks. So there are a number of complications that effectively translate into much higher bit rates and CDNs that struggle to perform their role, because it's not just about how many servers and how many caches you have around. It's also bottlenecks can really be anywhere. Also, there is an issue of emotional importance. If, for whatever reason, today you cannot watch the film that you want to watch, it's not a big deal. You can do it tomorrow. If today, in that moment, when you connect to watch a ball game, you cannot watch it, you become probably like that guy over there, a bit rageful. And also, the quality of experience, the meaning of quality of experience is very different, because while you can enjoy a film at 360p with good audio is still enjoyable, at 360p a football game is unwatchable. There's no way to see the ball, no way to recognize the players. So quality or resolution, much, much more important than they are for VOD. And as a consequence, people become angry very quickly when they don't see something of that quality, which they are used to seeing with normal TV. And then the other problem is how many people are watching live events? A lot. An average event, not just in the US, but even in the average European country, typically gets millions of same-time viewers. In my mother country, Italy, an average Serie A game, 3 to 5 million viewers. That's a lot. For streaming, this equates very often, if you want to do that in full HD, well over 10 terabits, 20 terabits, sometimes saturating the capacity of a lot of national backbones. So it gets problematic pretty quickly. Also, I just wanted to remind a few truths that sometimes we forget about the reality of data connectivity. So sometimes when we talk about 10 terabits, 20 terabits, that's a lot. And when we talk about, for instance, full HD requiring 8 megabits or 9 megabits for a good quality full HD experience, that's a lot. Very few people are able to see that. And sometimes we believe a little bit too much to the average speeds that we read in the news or in popular reports. First of all, because averages, even when they are right, don't mean much. For instance, here in the US, if you look at the latest Akamai report, average connectivity is north of 20 megabits. It's actually about 23, 25 megabits, the number. But the problem of these numbers is that the distribution is something like that. So when you're seeing an average, it's an average of something that has very few instances very, very, very far on the right, the peak connectivities, which typically happen in non-prime times or for selected lucky situations. Then you have a lot of situations that are back there, and the average, the mathematical average typically is over there in the middle where it means nothing. And then you also have a lot of people that in many cases disconnect because of poor service, and when they disconnect, you don't count them in the statistics because, of course, the statistics are made of what is transmitted, not what is not transmitted because people gave up. And so while in other industries, very often we measure percentiles, and at least the median, the 50 percentile, so 50% of the times you're worse than that is a very important number. Unfortunately, typically in this industry, we still publish averages. But actually, if we look at the percentiles, the picture that we get is very different. So, for instance, Akamai report for the US, as I was saying, about 23 megabits of average. This is actually the US last year. So the same numbers, just seen differently, and actually the average of these numbers is roughly 23 megabits. This is in 2017. The percentage of watching time, it's not actually the percentage of viewers, apologies for the glitch there. This is the percentage of watching time based on the bitrate that was available when the people were watching. So you can see that only 10% of watching time was made at more than 3 megabits. Despite the fact that the average was at 23 megabits, only 10% was higher than 3 megabits. The bulk was in between 1 and 2 megabits. The median is roughly 1.7 megabits, so less than 1/10 of the average. So if I go back to this number, you see that there is roughly a factor of 10 between the average and the median. And actually, almost 30%, actually 31% of the time, the bitrate is so low that it would be very difficult to follow a football game or something very sophisticated, because it would be an SD experience at very poor quality or no experience at all. By the way, people typically in the red disconnect. So if you look at the number of sessions are 3 times as much because the average length of the section is between 25% and 30%, because people disconnect because the quality is too poor, too much buffering, etc. So this is very important because we need to remember that this is the reality. So the bulk of people typically are hovering between 1 megabit, 3 megabits. If we are lucky with fiber, they are about 3 megabits. So if we want to serve them, we need to target these bit rates. We cannot target 9 megabits, 10 megabits, 20 megabits, because it's not real. We would get only a very, very minor percentage of the population. This is really what can scale. So how do we fix it? It sounds like, terrible, but in reality, there's good news, because there's an operator that has fixed it. And actually, this is a real service in production, in operation today, that is working, I would say, flawlessly, because in about 5 months of service, there was no service call, and it's actually a very costly service. Sky decided to launch a Sky over IP, which is the first instance on the planet of an unmanaged OTT service that is in reality a full bundle of pay TV. So it's not a $10 per month type service. It's actually the full-fledged Sky service, 60 euros per month, exactly like satellite DTH, same set-top box, same PVR, same service, just delivered via a managed OTT, 100% of the customers in full HD, so very, very ambitious. And it's one of the things that if it doesn't work, given the ARPU, people will complain immediately. So it's actually something that Sky, before launching, did a lot of analysis, and we were lucky enough to be part of it, so we could do those analyses with them, hence the numbers that I just showed you. And we could see, to our bewilderment at the beginning, that even fiber users, if you want to give them a reliable service, something that is as reliable as pay TV like as DTH, maximum must be 3.5 megabits. And this was a surprise also to us, because we would have thought, with fiber you can get to 10, 20, 30 megabits. No, if you want to be reliable, considering all the places where you can have bottlenecks, considering you're talking about prime time, et cetera, you need to stay between 3.5 megabits. The solution was actually using Perseus Plus encoding on Imaging Communications Selenium 1 headend. Sky is actually streaming full HD with two profiles, one at 2.5 megabits and one at 4 megabits. The 4 megabits actually delivers a quality that is slightly superior to the quality of the DTH service, which is at much higher bit rates than stat-maxed. And the 2.5 megabits is roughly similar, slightly lower, but imperceptibly lower. It's currently in production, no service call, excellent quality of experience. It's actually interesting to notice that we are talking about Italy, so the network isn't necessarily one of the best on the planet. And there are other live OTT providers that were recently in the news because they launched services that very much struggle to deliver quality and were even sued by consumer associations. They complained about the internet in that country. It's the same internet as this service. So it proves that if the internet is used correctly, even a relatively underdeveloped internet infrastructure can deliver pay TV-like quality. So how is that possible? So this actually shows that it's possible, and this was done with a combination of best-of-breed video delivery networks, so planning correctly the CDN delivery, and using Perseus Plus to reduce massively the number of terabits delivered, and also the bottleneck, the last mile. In order to do this, next-generation codecs are necessary. And of course, I'll be talking about Perseus Plus mostly because that's our codec, but in general, with H.264 alone, similar performances are just not possible. When we talk about next-generation codecs, this is courtesy of CSI magazine, when they were doing a nice article saying that in reality there can be no winner because all codecs need to coexist, which we very much agree with. There are a few options. In reality, the few options here, they forgot about VP9. In reality, it's actually H.264, there's VP9, there's AV1 coming, not really usable for now, HEVC, despite some licensing complications, but technologically speaking, is there. VVC will be coming in about 5 years. And there is Perseus. The interesting thing about Perseus is that Perseus is a very odd codec in this scenario, because aside from being a codec that can be used alone, it's also a codec that can be used in combination with any of the others. So it works a bit like an electrical engine, can work alone like in a Tesla, or it can work in a hybrid mode combined with any of these codecs. And in the Sky case, it was used in this second mode, which is called Perseus Plus, because it's Perseus plus something else. Next generation compression is key. So how do the options stack up in terms of different codecs and the business case or the problems that there are when different codecs are used? First of all, the first question to ask ourselves is it really worth it to use a next generation codec? Should we really start using something different from the tried and tested MPEG-4 part 10 H.264, or AVC H.264. Does it really deliver value that pays off for the effort? The second question is, given the alternatives, what's the device support? So if I adopt a new codec, how many people will be able to watch it? And does this mean that I need to replicate my service multiple times for the old devices and the new devices if the new codec is not capable of serving also the old devices? And then the third one is costs. How much more costly will be my whole delivery chain given the choice that I make? And so how can I measure the business case for the choice? So if we go into details, first of all, let's take a look at the gains. So how important is it to improve the quality of delivery? Do people notice? Does it matter to revenues and to quality of experience? So first of all, if we look at numbers, how many of you were at the session this morning about AV1? Actually, a couple. I was actually pretty happy because it was a very nice session. The problem is very often when I hear those numbers, I get frustrated about the fact that very few people know that we already have in operations, while people talk about future performances of AV1 that will deliver in a few years a certain performance, we have already live services in operation with Perseus Plus at lower bit rates, higher qualities than those. When I was hearing the numbers, I was like, we have stuff in production that is better than that for live, not VOD. So the curves are something like this. This is a representation of a Netflix type, exactly what the Netflix people were talking about today, Netflix type rate distortion curve. So playing also with resolution, not at same resolution, but also allowing for the fact that instead of making a codec collapse, it's better to lower the resolution at some point. And it's important to stay in what they call the convex hull, so in the place where a codec performs best. And this is the curve for AVC H.264, for HEVC VP9. In reality, VP9 is slightly lower performance than HEVC. AV1, in reality, so far, personally, in our experiments, we haven't been able to show better performances than AVC, but in this graph, just to avoid, to elicit any rage from AV1 people, I put what they claim more than what we see, but maybe they will get there. Perseus Plus H.264 is what we have in deployment. Perseus Plus HEVC VP9 is slightly there. By the way, here at Streaming Media, aside from being able to prove the Perseus Plus operating points, I will tell you how later. So also on your devices, you'll be able to see it. For what concerns Perseus Plus HEVC, we have at the Xilinx booth a live demo that you can see with your eyes with 4K EP50 at 10 megabits. And, or 8 megabits, I don't remember, but in any case, it's a live demo, so you can also play with bit rates and content. So essentially, this is what happens in general. Of course, like any generalization, different content, different preferences can slightly vary these curves. So for instance, in a real curve, this is an example coming from a customer trial that we did last week. So it shows, in this case, it's with VMAF, so not necessarily the best way to measure something. Codec subjective performance is always best, and metrics are not necessarily calibrated for Perseus. But this shows the type of benefits, essentially are visible. They can be seen also with any metric, can perceive them. And they can be substantial because even here you can see that essentially a 1080p 60 at 3 megabits performs on average at a VMAF quality like a 5 megabits, but it's also a higher resolution, which means in simple scenes it's much sharper. So aside from being overall same quality, despite 40% less bit rate, it's also quite sharper. I had also some examples to show. Unfortunately, the projector is not high quality enough to to show it. I had also a video, but probably it's better if I show you something else. But essentially, here in this example, you can see a depiction of what it means to have a higher quality. Sometimes I feel it's a bit like putting on a couple of dioptries of eyeglasses, and it allows you to read better. For instance, you can see the AT&T Stadium. You even understand that it was empty letters. You start understanding what's going on. You don't have all that horrible aliasing. When there are things like these, you can see faces that otherwise are all blurred. There was a nice moment in the scene where in the previous case, you cannot even see if it's a woman or a male, and in the Perseus case, you can see it's an Asian woman. So similar situations. When you have stuff like that, you can read text much better. You can understand, you can read logos much better. There is much more detail in moving objects. So it really does make a difference. It's really perceivable. It's not just a dumb 30, 50% that people wouldn't care about. People do care about this. It's really valuable. Again, I wanted to show you a video, but it's probably not the best thing to do because of the projector, because otherwise it would be difficult. But I'll show you another thing, which is actually, considering that also today at the AV1 demo, they used the analogy of imaging also to show why a codec works, and actually also that is something that I agree with. And so I will show you one thing that shows why Perseus works so well with the case with imaging. So this is Perseus used for images, and this is a normal browser, so without any plugin, just using normal JavaScript. So this is a JPEG example of an aerial image. It's actually a fairly large image, so you can see that it takes quite a lot of seconds to load with JPEG. And this is the type of performance that you get with Perseus. Again, JavaScript. Normally, I can replay it. Just it's not caching because it's an incognito tab. Normally, we get from 3 to 5 times faster performances. This will be also public in a while. We'll make it available both for video but also for imaging, because it's pretty cool to speed up. So this is, for people that were at the AV1 image format thing, this is already compatible with all browsers, 100% of browsers. It delivers better performance than what was shown today. And it also allows transparencies, animated sequences, HDR, and wide color gamut. So it does work in short, and it matters. Again, this was imaging, but it's just to show it does matter. People do notice the difference. Quality of experience changes significantly, and it's so easy to do it because the very fact that it works on any browsers just with JavaScript is a testament of how low complexity it is, because it uses the graphics pipeline. And this actually brings us to the second point. How compatible is the codec? What's the device support? Because if we need device support, if we need operating system support, if we need browser support, if we need support from streaming protocols, etc., yes, of course, only a phenomenal alliance of hundreds of companies can do it, and it'll take many years before deploying. If instead it uses what's already out there in terms of devices, software support, browser support, etc., then you don't need to duplicate stuff. And support takes a long time, even when you're a standard. This is HEVC. Today, this was taken a few days ago. There's a nice website that says, called Can I Use? I don't know if you've ever used it. And it says how many devices out there, according to users, are able to receive a certain technology. HEVC was actually standardized in 2012, 6 years ago. After 6 years, 18% of current browsers can decode it. It's good that it's 2 digits, but it's actually a little bit too few. And more devices can actually decode it with software libraries or native code, but for browser delivery, that's the picture today. VP9 is actually even worse. 4% of browsers are actually able to decode it by default. There's another 25% that can be enabled by tinkering with the browser and enabling specific scripts. Again, huge support, Google behind it, Alliance, etc. is still very difficult. So, of course, any of these two codecs, and AV1 is, of course, 0% right now, any of these codecs would require duplication of workflows. So if you want to use it, unless you start using it only in a specific device, if you want to really go multi-screen, you need to duplicate the workflow. So to do both H.264 and the new codec. They are excellent codecs, though, so I'm not saying not to use them. And so we are very supportive of both HEVC and VP9. This is actually the type of support of turbocharging H.264 with Perseus Plus. So Perseus combined with H.264, Perseus Plus H.264, 95%, but it's actually 100% because Opera Mini and AB actually browser cannot decode H.264 either. So it's actually, in reality, all browsers that can decode video can decode Perseus Plus H.264. So support is exactly the same as AVC H.264. And this is via plugin-free HTML5 because it uses just simple graphics instructions like overlay. This, of course, matters because it means the difference between creating multiple workflows, which cost money and complexity, or having a single workflow that can serve the same quality to all devices. So in one case, it means complexity costs and serving the top quality only to few people, maybe 20%, 30%, 5%, but not 100%. In the other case, it's possible to serve that quality or better to 100% of the people. Then it's a matter of costs, and also encoding costs is particularly important for live, because while for VOD it doesn't matter, because in reality one can use off-peak processing power that costs very little. For live, processing power is very costly. Here we put some numbers. These numbers are admittedly very conservative, so very few people can actually spend this money. A lot of operators spend more than this. But they are indicative for large operator volume costs. So we have the case of AVC H.264. And of course, these vary depending on the codec used because there are more efficient codecs, less efficient codecs. So these are based on standard and widely applicable cases. H.264 case, if you use HEVC, you also need to use H.264 for most cases. Of course, corner cases are possible. If it's only 4K, one can use only HEVC. But in normal delivery, must use two codecs, VP9 plus H.264, AV1 plus H.264, or Perseus plus H.264. You can see that for an operator delivering HD, the differences in cost can be quite substantial. Even at these low costs, the savings can very easily equate to hundreds of thousands of dollars saved per year. In other types of costs, for instance, in the streaming media survey, they were actually claiming that an hour of live video would be with H.264 between $10 and $25, so the numbers would be 10 times higher. In our experience, they tend to be lower, so we prefer to put these numbers which more correspond to our experience. For our UHD, also the difference can be striking, because in that case, it's a 4x difference, which matters. And again, also on the 4x difference at the Xilinx booth, we have an example that actually describes the 4x encoding efficiency. Example of measurable benefits are something like this. So it's possible to measure this stuff pretty simply and pretty quickly, because it's all things that with a simple A/B test can be put in place in days. Even a public operator with whom we've done a trial on 3 million people, they went live on 3 million people after 3 weeks from kickoff So it's a pretty simple thing to do. But comparing a normal HLS ladder, on the left you see a typical HLS ladder inspired by Apple recommendation, HLS recommendations. On the right, a ladder that in this case is not really an equivalent ladder because it has a higher quality, because it has higher resolutions and higher quality for certain profiles, but it's in this case the ladder that the operator chose. It's very easy to measure the percentage of viewing time in HD. In this case, more than 40% of viewing time migrated from SD to HD, which actually matters to viewing quality. 3 times faster video startup time. Of course, very important for a number of things. 65% reduction in CDN publishing load. Very important doing live events. Essentially means tripling same time number of people, more or less. And very strong reduction also in unit cost per minute of CDN. Paradoxically, this operator didn't save CDN costs overall because traffic increased, so minutes of viewing went up to more than offload the reduction in CDN. So what I normally tell people is that we won't save at all CDN costs. We will probably increase them, but for good reasons, because they will stream more, because people will not disconnect due to buffering events. And so they will be happy because they will make more money out of advertising and subscriptions. And most importantly, a single ABR ladder for all viewers. So this is the quality that was served to 100% of viewers. So essentially, there are 5 options. And again, consider that, of course, being Vinnova, I push for the latter, but the reality is there are 5 options, and they're all very real, and people can choose any of them. The first option is doing nothing, staying with H.264. Easiest possible from an operating and technical point of view, but the reality is there's no way to achieve TV-like quality of experience with H.264 alone. The second is actually H.264 optimizers. There are great things done by H.264 optimizers for VOD, much more difficult to achieve similar gains in live. So typically, the gains in live delivery are insufficient. And it's also difficult to apply them. It's not just that they are insufficient, but there's not even time to perform certain optimizations, or optimizations related to cap the variable bitrate do not apply because it cannot work effectively with live delivery. Third option is migrating to HEVC or VP9 or AV1, depending on the particular choice that an operator can have. The problem here is device compatibility, still low for all of the 3 with different nuances. There is better quality, but it's only for some of the users. So it's not a larger chunk of the users would be left with suboptimal quality. It tends to be expensive in terms of processing, and there is complexity of workflow duplication. Then the fourth option is Perseus Plus H.264. That actually has the beauty of device compatibility. It's actually a great quality for 100% of the users. And it has the lowest cost with a single workflow, because there's only one workflow and it costs less than an H.264 workflow. It's also important, however, and with a lot of our customers, we're talking about the fifth because it has a lot of applicability in certain cases. And that's why we are showing it here at S3 Media, to also go for combinations where Perseus Plus is used in combinations with either HEVC or VP9 or AV1. The approach actually brings even more benefits to HEVC, VP9, and AV1 than it does to H.264, almost surprisingly also to us. In this case, of course, the compatibility and the workflow duplication is the same as the base codec. So, of course, in general, it will have that problem. But it's the best quality per bit. So for operators that really want the very best quality per bit for users that are capable of decoding HEVC or VP9 or AV1, that's the best choice. And in any case, the use of Perseus Plus reduces the cost of encoding of about a factor of 4, which can make the option much more digestible also for live delivery. And of course, all 5 options are perfectly viable, and different operators will choose one of the 5. Is it the right time to work on this? Of course, a lot of operators are doing different things, but we argue what this says. Very often, we tend to say it's not the right time, but in reality, delivering TV-like experiences is the key problem to unlock monetization of live linear services. So we would argue that among all the priorities of making the app work and sorting out server-side ad insertion or whatnot, sorting out the fundamental element of quality of experience is a key priority. How to do it if one wants to choose either the 4th or the 5th option? There are a lot of professional and open source solutions that are ready for deployment. So here I close just with a little commercial of how to do it if you're intrigued. On the encoding side, there are a lot of options growing. And we hope that more and more vendors and more professional solutions will adopt the format, which is absolutely usable by anybody. Telestream already offers a service. Imagine Communications headends. Xilinx, here we're showing it. Also, we are combined with NG Codec. I see there Oliver. And we're doing great stuff with our fabulous codecs. NTT Data and also FFmpeg. So there's also an open source FFmpeg open source for what concerns the integration layer version. And then also on the decoder side, there is integration with all the main open source players for Android, for iOS, Shaka Player, Video.js, HLS.js in browsers, Windows MFT, professional players such as Theo Player and Visual On, Android TV, and again, growing, and it's a fairly easy integration, and we're trying to facilitate as many integrations as possible. It's also easy to try. If one wants to try Perseus on your own content, there's a cloud platform that we're putting available for people that want to use it. It's very flexible, very easy to use it for both VOD and live, and can be used to evaluate the output both on our apps that you can find in the app stores, or on your apps just by doing a pretty simple integration so that you can do an A/B test like the one that I mentioned before. And there's also a VIP beta program for the platform, since it's a demo platform that we've been using for trials, but now we want to extend it to a broader usage. We are promoting here at Stream Media if anybody wants to be in the beta program and shape the future of the platform, giving us recommendations on how to evolve it. There's a free trial available, so just ask me after this or just sign up at this link and you'll be able to trial it out. And there's also an app that is available on the App Store, and here are the credentials where you can see on your device stuff like the mobile 1080p at 1 megabit for live channels. There's a Sky News channel, so it's actually very evident that it's live and there are no tricks. And there are also other videos to check the live delivery quality achievable with Perseus. And also we have here Xilinx a demo, and you can see in real time the 4x efficiency of our HEVC-based solution delivered with Xilinx and also with NG Codec. And very soon, I'm looking at Oliver, will also have the Perseus Plus VP9, right? So at the next event, we'll also be showing that. And that's pretty much it. So any questions? I'm very glad to answer any questions. Yeah?
On the Skybox, the set-top box, did I understand you said that it's exactly the same box that they use for their satellite?
Yeah, exactly.
Why did they choose that instead of an off-the-shelf streaming box like Roku or something?
They also have it. They have a service called Now TV with a Roku box, but it's actually the typical OTT service at lower ARPU with a reduced set of channels and contents, etc. So they have that for the kind of lower cost type OTT, and they decided to launch a Sky over IP, which is instead exactly the same as DTH, so same experience, same box, same everything, same price. So it's just instead of putting the satellite dish, you get it via IP. Not yet. So far, actually, this was the first deployment. So hopefully, we plan to extend, of course. but the current deployment is on. We are deployed on that, and also we went also to all of their IP delivery set-top boxes, so also the old ones. So it's both on the new ones and also on 12-year-old boxes that they already had in the ecosystem. So we upgraded them over the air with a software upgrade, which was also a nice experiment because it was important for them to show that the codec is able to upgrade also very old set-top boxes, which are similar to what an X1 box, or actually a fairly old X1 box would be here in the US. So with 7125 Broadcom chipsets type box. And actually the point is the codec is very light. So essentially very typically it frees up resources versus H.264 native decoding. Any other question? Yeah?
So you were saying there is a case for all the different codecs.
Yeah.
So if you could describe the weaknesses in Perseus.
Yeah. Well, the weakness is very simple. It requires to touch the decoder. So, despite the fact it's a very, very simple activity, which typically takes a few man days, of course, it's not the same as delivering pure AVC H.264, because in that case, you do nothing at all. In this case, you need to put a script in the HTML5 page, or you need to upgrade your EXO player or AV Foundation player or whatever. So it's a very minimal intervention, but it is an intervention. So, normally for an operator, this means, like I said, when we deployed on a public broadcaster, we took 3 weeks just because they took a week to do it, 2 weeks of testing, etc. So it does require some work, and versus doing nothing, this means some man days. That's admittedly, there's nothing we can do about it. It's much less than any other new codec, but it's not like, that's why I was saying, if you really want to do nothing, either you stay with H.264 or you try to do some streaming optimization of H.264, but you don't get nearly the benefits that you get with Perseus Plus. So, it's a very clear trade-off. Yeah. Not yet. It's actually, that's why I was, we will soon have it, because with Oliver, the guy in front of you is the CEO of NG Codec, and with NG Codec, we are actually creating the first instance of a super efficient live Perseus Plus VP9 codec, and so as soon as we have it ready, we'll be testing it with a few large operators that are interested in it. So far, it's been just lab tests, but no deployment. So far, we've been using, for all deployments, Perseus Plus H.264. There's a lot of interest in deploying Perseus Plus HEVC. We haven't deployed it yet, but we are in a number of trials with Perseus Plus HEVC, which, of course, is much better quality and recommended whenever you can use it. Perseus Plus H.264 is greatest compatibility and great quality. Perseus Plus HEVC is by far the best quality. We expect from Perseus Plus VP9 something very similar to Perseus Plus HEVC. So that's what we expect, but we need to finalize the work to be completely certain that this will be the case. The density, however, will be kind of the same. So in terms of encoding density, the live density of Perseus Plus VP9 and Perseus Plus HEVC will be very comparable. Yeah, Apple TV is not a problem. Yeah, absolutely. That's super easy. Yeah, that's kind of iOS playback. So in general, yeah, everything that has an open architecture, so we can do the integration on the player, is extremely simple to do. If there is a set-top box that requires a specific intervention, so for instance, if Comcast asked us to deploy on an X1, we need to do a specific integration on their X1 box, which requires a few weeks of work plus testing. So for standard devices like Apple TV, it's already done. Yeah.
Question, maybe you mentioned that, catch it. If you were watching streams encoded in Persis, and you also had traditional streams in H.264 embedded in JavaScript, does it detect the two differences?
It's actually simple. If you get a normal H.264, it plays H.264. So Persis is put in standard enhancement information, the SEI metadata, like subtitles, etc. So essentially, if the decoder is unaware of Perseus, it will just ignore it and play a lower resolution. So there's an ultimate fallback that if you have a device that for whatever reason was not upgraded to Perseus, it'll still play back the video, it'll just play back a lower resolution, so it won't see the Perseus addition. Because Perseus in practice, when it's used in Perseus Plus mode, is used to encode like an overlay all the details. So you use a base codec at a lower resolution, which makes a DCT-based codec more efficient. And then with the specific scaling technique and the Perseus algorithm that encodes very efficiently details, you stitch on top the details like it was augmented reality using graphics instructions. So the reason for the compatibility is that it uses all the pipelines and the graphics instructions that are available for normal overlays, etc. So it's already supported by browsers, already supported by everything because it's needed for graphics. And if you just, and this is put in the SEI metadata. So if you alternate an ad, for instance, and the ad is in H.264, it'll just play back H.264. So every chunk can be independent, like in ABR, and so you can have a chunk with Perseus, a chunk without it, and the player will do it without any problems. Yeah. Yeah, actually, this is something that, hybrid ladders with different profiles, it's one of the things that we discussed also with the AV1 team. One of the things that we would like to do, we haven't done it yet, but I think that there is a lot of mileage in it, is using immediately AV1 for the lower profiles in the ladder, because in this way with Perseus, we can use an even smaller resolution, which makes AV1 decodable via software, even by low-power devices. Perseus can provide, like for instance, doing a 720p Perseus plus AV1, the AV1 part would be a 360p, which maybe is decodable in software even by a mobile device. The Perseus part would be transparent in terms of processing time. And so we could use for at least the two lower profiles in the ladder, make sure that AV1 can be deployed to all devices. So it's one of the things that we are exploring. We haven't done it yet, but we are pretty confident it should be doable. It's also doable today with Perseus plus HVC or Perseus plus VP9. So the approach is actually doable with all next generation codecs. So, definitely, at least for the lower profiles in the ladder, it makes a lot of sense to accelerate the adoption of HVC, VP9, or AV1 according to preferences. It's also one of the reasons why, when they understood it, initially people thought that Perseus Plus was slowing down the adoption of HVC, VP9, AV1. In reality, we believe that it will accelerate it quite dramatically rather than slowing it down. Yeah. I'm sorry? Well, actually, what the transcoder does, essentially, when it gets a video, it downsamples it, depending on the form factor of downsample it, and uses a base codec to encode it. This takes less time, so that's already a pretty big saving, which allows also to focus more processing power on the power-hungry codec, like VP9, AV1, HEVC, or whatever. And then the Perseus part is typically done in parallel with other parts of the silicon, so it's very light. Or if it's done in the FPGA, it can be done very, very in a lightweight way in FPGA. So from a encoder point of view, typically the benefit in processing power is disproportionate the more the codec is a next generation codec. So depending on what you use, and that's why you saw that for H.264, the benefits are typically 30–40% reduction in overall processing time. But for HEVC VP9, we're already 4 times. For AV1, so far, we registered 5 times less processing power. Then it depends also on the implementation of the codec, so it will vary, and also on the machine, so the type of hardware, whether it's CPU, GPU, FPGA, or whatever. But typically, the benefits are quite substantial. Also, when alternating the codec, it depends on the base codec. Not just the format, but also the codec. So there are implementations. As you know, there are implementations of HEVC that are faster than others. So X265 or NG codec or other implementations are all different in terms of VQ and processing time. Yeah.
So would it make sense to build a ladder where you have like a 540 encoded in ABC or HEVC, and you use that for a 1080 that was that same encoding, the exact same encoding with a Perseus enhancement layer?
It does make a lot of sense, and we discussed it with some large operators. We haven't done it yet, but in practice, it is possible. It needs to be studied, but it's possible with ABR because ABR now allows, like with audio, you can have a single audio channel that is used for multiple profiles. In the same way, you can have a base that is used for multiple profiles. So it could be done. We haven't done it yet so far, but we discussed it with a few people that are interested in trying. So it could be done. It's one of the possibilities of the layered approach of Perseus Plus. And it's also something that we are already doing with imaging, because with imaging, actually, we are doing that with some websites where instead of sending different transcoded images for different devices, like mobile devices, tablets, when you keep it vertical, horizontal, etc., there's a single high-resolution asset, and then the decoder calls the different parts of the file depending on the target resolution. So a similar thing could be done also for video. It's just not done yet. So possible, not done. Yeah. Thank you very much. Then, thank you.